Hi, welcome to the lecture number 57 of fuzzy sets, logic and systems and applications. In this lecture, I will continue our discussion on Larsen fuzzy model. Here, in this lecture, I will discuss the single rule with multiple antecedent for Larsen fuzzy model. Now, coming to the second case here of the Larsen fuzzy model, and in this second case of Larsen fuzzy model, we have the model which is characterized, which is defined by single rule, only one rule, with multiple antecedents. So this is very important to note. So we already know that how will the rule of this kind of model will look like. So we see that we have the rule here, and this rule, since the model is defined by only one rule, so you see only one rule we have, a single rule. But this model is defined by single rule with multiple antecedents, so we can have multiple antecedents. For simplicity, we have here only two antecedents, but it can be even more antecedents. So we have here two antecedents, and both the antecedents here, x is a and y is b, are connected with a connective, that is and here, but it can be or also, or. So either we use and connective, or we use or connective, or we can use any other connective also in between the uh, two antecedents, any two antecedents. So we see that this kind of rule will look like this kind of fuzzy rule will look like this. So if x is a and y is b, then z is c. So this is our premise part, and this is our consequent part. So we have in premise part two antecedents, as I have mentioned. Now, if we have a Larsen fuzzy model which is characterized by this rule, this kind of rule, now if any unknown input comes to this model, so this input can be either fuzzy or uh, crisp. So let's now discuss this one by one. So here in this case, we have the fuzzy rule, the single rule is our single rule, and we have multiple antecedents. So we have first antecedent, and then we have the second antecedent. This must be noted here, that we have in this kind of uh, multiple antecedent, we have only two antecedents. We can have so many other antecedents also. So I mean, we can have a few more antecedents or more antecedents. So here, for simplicity, I have taken only two antecedents. So first antecedent here is x is a, and the second antecedent is y is b, and both are connected with the connective and. So we could have, as I mentioned, we could have any other connective like or, r. So let us now apply the fuzzy input first. So here we have this as the fuzzy inputs. So we are now supplying Larsen fuzzy model, this fuzzy input. So I can write this fuzzy inputs. So if we supply this fuzzy input as a dash, x is a dash, which is fuzzy, and y is b dash, which is also fuzzy. So when we supply this input, and so x is going to the x part, means x antecedent, first antecedent, and then y is the fuzzy input b dash is going to the second antecedent. So when we superimpose here these two fuzzy sets like a dash and a, we see that we are getting the point of intersection. So we are getting only one point of intersection. As I mentioned earlier, that we could get many points of intersection. So in those cases, normally we get two. So in all the cases, if we are getting multiple points of intersection, then what we do, we take the maximum of this. So here, since we are getting only one point of intersection, we call this as W1. And here we are getting the another intersection. So let's call this as W2 of rule 1 of rule 1. So I can write here W1, and here I can write so W11 and W12. So then what we are getting here is that we take the min of these two weights. As I've already mentioned that the we call either weights or we call the firing strength of the rule. So what is the firing strength of the rule is W here. This is the final firing strength of the rule. Is called the rule weight. The rule weight or firing strength of rule. Alright, so now since we have two weights here, two membership values here, so these are nothing but the membership values are grades. So we take the min because we are using max min composition here. So when we take max min composition, we use the min of these two. So we see that when we take min, we are getting this value. So min of the two will be 0.36. Now we'll use this to scale down the height of the fuzzy set C. So output fuzzy set is C. So we'll bring this down to here to this value 0.36. So let me repeat here that the height of the fuzzy set we will bring down to the 0.36, and we know how did we get this value, value that is 0.36. So we bring the height here of the C fuzzy set to 0.36, and I already mentioned that we can get it very easily. So what we do here, we just take this W as 0.36 and then we multiply it with simply mu B as the membership function of the fuzzy set mu B, which is characterizing the output fuzzy set C. So this is this mu C, not mu B. So W into mu C Z, and this is going to give me mu C dash. This is going to give us mu, I can write here mu C dash and then Y. So this is how we get mu C dash Y, and then from here we can write the C. So what is C dash here? C dash will be nothing but the fuzzy set defined in terms of mu C dash Z. No, this is not Y, this is Z. So this is Z, and then here we have Z, this small z. This is small z. This is also small z. So this is how we get this fuzzy set as the output. This is Y is equal to B dash. So This is very simple, and we have seen that we uh, have a Larsen fuzzy model which is defined, which is having only one rule but with multiple antecedents. So when we supply the fuzzy value as inputs, so this is how we are getting the fuzzy output, and this fuzzy output is the C dash here in this case. So here we have compared, here means we are comparing the output values for the same input when we use Mamdani fuzzy model and Larsen fuzzy model. We get here in this case our C dash like this, and here, and when we use Larsen fuzzy model we get this output. So we see that when we use Mamdani fuzzy model, the W that we have gotten, the weight of the rule, the firing strength of the rule that we have gotten, is used to simply chop off the fuzzy set, output fuzzy set, means to truncate the fuzzy set. But here in Larsen fuzzy model, the same value is used to reduce the, to scale down the output fuzzy set. So this is how we can see, we can compare the outputs of the Mamdani fuzzy model and Larsen fuzzy model for the same input. And here the input is the fuzzy input. And here in this case, let us use the other composition, composition, that is max product composition instead of max min composition. So since we have multiple antecedent here we have in this case, particularly in the rule that we have here is having two antecedent, which is the case of multiple antecedent. So here the max product composition will give us the different result, because there in the first case, first composition, we have taken the max min. So we took the firing strength, the minimum of the firing strength, minimum of the firing, minimum of the weights, and which was in the previous case 0.36. But here the inputs remain the same. For the same input, we are getting here these values as W11, and here we have W21. So here, since we are using max product composition, so we have to take the product of these two. So simply W will be nothing but W1. I can write here W1, W1. And so here also W1. So there is 1, and then we have the W. Sorry. W. So here this is W1. This is for the first rule, single rule. That's why. So whether we write it or not write it, doesn't make any difference. So let us not use 1. Okay. So when we multiply, we get, multiply the two, W11 and W21, we get the rule of the firing strength of the rule. So this is firing strength, or the weight of rule, which is W is equal to, which is W is equal to 0.21. Here we have got 0.21 because we have multiplied the 2 points of intersections, these values. So this is less than the previous case where we use max min composition. So please note this. And with this, now when we scale down, So the output, so let us now scale down. So when we scale down the output here to, let us scale down this to 0.21. So this is scale down here. So what we are getting here is this output, because we have single rule, so max doesn't make any difference. See, max of this will remain the same. So here we are getting this as the output, the fuzzy output corresponding to the fuzzy inputs. So this is here. This is the fuzzy output, and this is nothing but the C dash. And what is C dash? C dash is nothing but the fuzzy set defined by here mu C dash Z by Z. So this is how it is defined. Now let us compare this output with the Mamdani fuzzy model. Let us compare the Larsen fuzzy model output with the Mamdani fuzzy model, and we can clearly see the difference here. The rule strength, the firing strength of the rule or the weight here is the same in both the cases, and with the same rule strength, the firing rule strength, uh, we when we truncate the output fuzzy set, we get this as the output, whereas here in Larsen fuzzy model we scale down the height, we scale down the fuzzy set. So we see the difference in the output for the same fuzzy input, for the same fuzzy input. Alright, so now let us compare the Larsen fuzzy model output again in the case of max-min composition. So we have two compositions that we have used here. So here, since we have the antecedents multiple case, and here in our case we have two antecedents. So since we have two antecedents, so max product and max min will make the difference. So here we see the Larsen fuzzy model with max product composition, the output, and here we see the max min composition, but for the same fuzzy inputs. So we see the difference as to how we get the output for the same fuzzy inputs. And we see here again the difference in between the Mamdani fuzzy model output and the Larsen fuzzy model output. Now let us go to the crisp inputs here. So in the second case itself, let us use the crisp inputs instead of fuzzy inputs and see what we are getting. So the rule remains the same because we are uh, dealing with the Larsen fuzzy model with single rule and multiple antecedents. So this remains the same here. And now when we supply the input to this model here, x is equal to x1 and y is equal to y1. So both the inputs we are supplying here, and both the inputs are crisp inputs. Both the inputs are the crisp inputs. So let's see what we are getting as the output when we use the Larsen fuzzy model using max min composition. So let us take the two crisp values. That means our x1 is, let's say, 6.5 here, and y1 here is the 8.5 as the crisp values. So you can choose any value which should be applicable, which should be falling within the fuzzy region, and should be in the universe of discourse, within the universe of discourse. So here in this case, we are taking, for simplicity, x1 is equal to 6.5 and y1 is equal to 8.5. So we see, when we take the x1 is equal to 6.5, and when we draw a line parallel to the y-axis, that means the parallel to the ordinate, that means the mu ax here. So we get the point of intersection here as mu as w1, let's say w1. And since we have only one rule, so we need not write this. So let's say this is w1 is equal to this, and w2 is equal to 0.36. Now since we are using the max min composition, so let us take the minimum of these two. When we take minimum of the two, yes, so this was nothing but the w1, this was nothing but the w2. So when we take the min of these two, we are getting 0.36 here. Now again, as we have done in the previous slides, since we are dealing with Larsen fuzzy model, so we have to scale down the height of the original fuzzy set of the output. So C, that is capital C here, the fuzzy set. So the height of the fuzzy set we will scale down to, we will bring down to here, to this value W. So this W is equal to 0.36. So we'll use this value here and we'll bring the height here. Accordingly, the fuzzy set will be scaled. So the formula that we use here is, we get the new fuzzy set like this. The membership function of the new fuzzy set, let's say mu c dash, let's say mu c dash z, and this is nothing but the W into mu c z here. So this way we'll get the output membership function. And here this fuzzies, the output fuzzy set here will be c dash, and this you can represent by simply mu c dash and then this. And since we have only one rule, so max is really not applicable here. Is whatever outcome that we are getting here will remain the same. So now let us compare this Larsen fuzzy model output for the input that we have supplied with the Mamdani fuzzy model. So let us now compare. We see here that for max min composition we get Mamdani fuzzy model here, truncated output, truncated fuzzy set, whereas in Larsen fuzzy model we get the scaled down fuzzy set. Now let us move ahead, and for the crisp input, let us use the max product composition. So we see that here in max product composition here, let's quickly use this. So since we have already found the points of intersection, point 81, so we can write here as W1 and we can write here as the W2. So here in max product composition, we'll simply, instead of taking the min, we'll take product of these two. So we take the product here, W1 into W2, and we get the rule strength, the firing strength of the rule, or the weight, final weight of the rule, is equal to, W is equal to 0.29. You can see here. Now this value will be used to scale down the original fuzzy set, which is the output fuzzy set, to this value, to C dash. We call this as the C dash. So here, so this way we scale down the output fuzzy set, and we have already seen that as to how we write the output, final output. So here, since we have a single rule, so max is really not applicable. We have only one, whatever output comes will remain. So fuzzy output is C dash, and C dash is what? This C dash is integral Z mu C dash. This is small z. And this is how this will be represented. This output will be represented. Now let us compare this output with the output of Mamdani fuzzy model. So we can clearly see that when we have used the max product composition, so how we get the output in case of Mamdani fuzzy model and in case of Larsen fuzzy model for the same crisp inputs. Now let us compare all the outputs, like when we have supplied the crisp inputs and when we have used the max product composition and max min composition, how these two models, Mamdani fuzzy model and Larsen fuzzy model, are giving the fuzzy output. And as I have already mentioned, that this fuzzy output is not the final output. Basically, further we defuzzify this fuzzy output using the suitable defuzzification method to get the crisp value. So we can here see that we can compare the outputs of the Mamdani fuzzy model and Larsen fuzzy model for the crisp inputs, for the same crisp inputs, and in case of the max product composition and the max min composition. In today's lecture, we have discussed the Larsen fuzzy model using max min composition and max product composition for single rule with multiple antecedents. So with this, I would like to stop here, and in the next lecture, we will discuss the Larsen fuzzy model for multiple rules with multiple antecedents, and we'll discuss the example also on the Larsen fuzzy model. Thank you.